So, our second topic is complements and receiving of this. So, sa complements and PCD numbers, meron pong unsigned and signed binary numbers. Ano po? So, yung unsigned first. So, binary numbers can be represented in signed and unsigned ways. So, unsigned binary numbers do not have signed bit, whereas assigned binary numbers uses signed bit as well, or this can be distinguishable between positive and negative numbers. Assigned binary is a specific data type of a signed variable. So, ano po ba yung ating mga data types? So, ano po yung mga data types natin? So, recall lang, yung mga data types natin, magkimikahan, history, ink, ano pa? So, binary number representation, so, yung dalawa. So, kapag unsigned, siya po ay positive only. Ano po? And then, naman kapag signed representation, yan ay positive and negative numbers. Ano po? So, unsigned, positive, and assigned, positive and negative. And then sa sign representation, meron pong sign magnitude 4. So, first complement, what's complement 4, and who's complement 4. And then sign magnitude 4 includes two zeros. And then one's complement, two zeros, and two's complements ay only one zero. Ano po? So, unsigned numbers don't have any sign. These can contain only magnitude of the number, so representation of unsigned binary numbers are all positive numbers. Yeah, so unsigned binary integers are numbers without positive and negative sign. So here are all things representing the number will represent the magnitude part of the number of the units will remain reserved for the sign bit representation, and unsigned binary integer is a fixed point system with no fractional digits. With no fractional digit ay yung mga 0.5, iba po, yung mga half, one third, one fourth, wala pong ganun. So, unsigned numbers are positive only. So, yung table na nasa baba, 5, yung unsigned binary notation niya ay 0, 1, 0, 1. So, tanda pa ba kung pagpuka ng binary numbers? Kapag 0, siya po ay offset. And then, kapag 1, siya po ay onset. And then, yung number 13 ay 1, 1, 0. And kapag 0, 0, 0, 0, yung number which is 0. And then, si 15, 1, 1, 1, 1. Maximum number which is 2 exponent of 4 minus 1. Next. So, sign numbers contain sign flow. So, this representation distinguish positive and negative numbers. So, this technique contains both sign bit and magnitude of a number. For example, a representation of negative decimal numbers, we need to put negative symbol in front of even decimal number. So in arithmetic operation, it is important to consider the sign, the positive or the negative of the numbers to be calculated. So in elementary mathematics, the operation of the sign numbers may lead to a slightly different result. Ano ba? So the sign binary operation can perform using one's complement and two's complement. And then sign binary numbers are decimal represented ano po, as binary numbers with the most significant bit as the sign, 0 for positive and 1 for negative. Ano po, 0 for positive and 1 for negative. Yeah, so what is complements? So complements is used to bridge the computer for simplifying the subtraction operation and for logical manipulation. Okay, so one's complement, the idea of the one's complement is to invert the digit of the binary number with a negative sign. So, kapag po sign magnitude, siya po ay uh, wala pong negative. Alam, para po siyang unsigned. Unsigned pala siya, unsigned. So, ang gagawin po ay, kunwari, yan, so 5, 0, 1, 0, 1. Ano po? So, perform the following operation using four-digit binary operation. The most significant EMSP is used to show the sign of the number. Only the numbers with negative sign are to be complemented. So, yung mga may negative number sign po ang meron, siya lang po ang i-complement. Ano po? So, after all the negative sign are complemented, perform addition operation to the numbers. If there is an extra number beyond 4 digits, add this number to the result. So 5 minus 3. So convert the decimal to binary first. Ano po? So 5, 0, 1, 0, 1. Ano po? And then negative 3. So 0, 1, 1. Dapat siya. Ano po? So 0, 1, 1 lang dapat. So meron pong 1 sa harap dahil po sa negative. So negative 3. So yung 1 sa harap ay, ang gagawin po ay, ano, perform ang addition operation to the number. So, ibababa nyo lang po yung ano, so, 1 plus 1, ang mangyayari po sa kanya ay 2. Ano po? So, ang sagot po dyan ay 0, 1, 0, 0. So perform the following operation using four-digit binary operation. So the most significant bit and is used to show the sign of the number. Only the numbers with negative sign are to be complemented. Okay, same process. So the ones complement is for the first negative, and the second complement is for the second negative. So 1, 0, 1, 0. And then yung kanina, 0, 1, 1. So, dapat siya po ay magiging positive. Kaya ano po kayong result? Ano po, since the result is a negative number, we need to perform another complement on the result. Ano, no. The second complement includes all the numbers with the sign. Yes po. Jem, ano po sabihin?
Ma'am, naririnig daw po yung background. Mas malakas daw po yung background.
Okay.
Thank you po.
Okay, going back. So, yung negative lang po ang i-complement. Ano po? And then, yun po lahat po ng onset sa one's complement ay gagawin po offset. And then, lahat po ng offset ay gagawin onset. So, kunyari po, ang example ay 0, 1, 0, 1. So, ang nangyayari po dyan ay 1, 0, 1, 0. Ano po, magkakanya po yung kanyang binary. Ano, offset, onset to offset. Ano po? Okay, ayan. So, kanina, ang atin pong example is yung negative, may negative. Ano? So, paano man po kapag addition? Ganyan lang po. So, 0, 0, 0, 1, 0, 0, 0, plus 5, ano? So, 0, 1, 0. So, pag-aalin na po lahat ng 1. So, 1 at 0. So, 0, 1, 0 plus 1 equals 1, and then 0, 0 equals 0, and then 0 plus 1 ay 1. So, the answer is 30. Ano po? 1, 1, 0, 1. Ano po? So, ang sabi po dito, sign bit is 0, so the result is a positive number. So, kailangan po, siya po ay mag-start with 0. Ano, kaya po, di ba kapag tayo ay nagpa-compute, ay kung ilang bit po siya. Ano, kung 4 bit lang, 8, 1000 lang. So, dito naman po sa ones complement, gagamitan niyo po muna siya ng 8 bits. Ano po? So, kita niyo po dyan, nagsimula po ng 4 na 0, and then tsaka pa nag-1, ano, si 8. So, yun po. Kailangan po ay 0 mag-start for the result of the positive. Ano po? And then, yung sa kabila naman ay, yan, ay mas madali po. Representation. Ano? So, 0, 0, 0, 1, 0, 0, 0, plus negative 5. So, kapag may negative, ang kanina, sabi ay, ang 1 ay ano, negative, and then yung 0 ay positive. Ano? 0 ay positive, 1 ay negative. Ano? So, anong ginawa po dun sa 1? Then, discard and carry. Then, 2. Ang ginawa po ay add 1 to the result. So, kailangan ang pinakaunang number niya ay 0. Ano po, para maging positive number. So, the answer is 0, 0, 0, 0, 0, 0, 1, 2. So, ang answer is 3. Ano po? So, naunawaan po ba? I-recall din po natin ito sa face-to-face. Sa mga hindi po naunawaan po ba? Kahit pa paano. Naunawaan po ba?
Paano nga po naging negative 5?
Given lang po yung 8 and negative 5. Parang representation lang po siya para makita kung paano ginagawa yung positive. Yeah. Next. Okay, so paano naman yung post complement? So, kailangan magawa niyo muna yung ones complement bago yung post complement. So, the idea of the post complement is to invert the digits of the binary number with a negative sign and then add 1 on the least significant LSB. So, sa ones complement, ang ginagawa po ay yung MSB. Sa two's complement naman po ay LSB. So, perform the following operation using 4-digit binary operation in two's complement. So, same given number, si 5 and negative 3. So, 0, 1, 0, 1, and then 1, 1, 1, 0, 1. So, gagawin po siyang 1, 1, 0, 0. So, yung offset, pinalta ng onset. Ano po? So, anong ginawa ay 1, 1, 0. So, inad po yung LSB, least significant bit. So, the excess 1 will be discounted. So, ang sasagutan po niya ay 0, 0, 1, 0. Ano? So, the answer is 2. Kaya 0, 0, 1, 0. Ano po? Parang ano lang po siya. Yung decimal number. Minus 5 minus 3. 2. Ayan. So, ito lang po ay sa binary. Ano po? Okay, so for digit binary, operational two's complement. So, since the result is a negative number, so we need to perform another two's complement in the result. So, 1100 plus 1. So, the answer is 1101. And then yung kanina, 0010 plus 1. So, kaya po siya naging 0011. Ano po? And then, ang i-add po dito sa two's complement ay yung LSB, least significant. Bit, ano po? Another example. Okay, so kapag pinigyan po kayo ng given number, i-convert nyo muna po siya sa binary number. Ano po? After the binary, compute one's complement and then two's complement. Ito pong nasa left image. Ano? So, ganyan lang po. Papatan lang ng tinan niyo yung binary number. So, 110010. So, papatan lang po siya. 001101. Ano po? So, yun na po yung ones complement. Pero kung yung given po niya ay may negative, so perform the ones complement. Ano? So, plus the MSP. And then kapag naman two's complement ay take one's complement and then add one LSB. Ano po? So, 001101 plus 1. So, yung two's complement niya is 00111. Ano pa? Two's complement. Ayan. Sa right side, take one's complement and add one at LSB. For example, yung nasa right side, yung 10101100. So, kapag po natin-compute na one's complement and two's complement, lagi po siyang 4 bit at 8 bit. Ano po, tandaan po na 4 bit at 8 bit. So, one's complement, add 1. Nakita po yung plus 1. And then two's complement, 01010100. And then, ano pong ginawa? Nag-plus 1. Ano po? So, the answer is 01010100. Ano po? Example pa na isa. And na pala yung PowerPoint naman ay isasend ko after. And ang nakalagay lang kasi dito ay hindi pa makapag-add kasi full storage yung drive. Ano? Wait. example po ay, example, nakikita po ba?
Yes po ma'am.
Ayun, baka kasi siya kita. So, one, for example, 8 bits. So, 1, 0, 1, 1, and then 0, 1, 0, 1, 0. So, we want to complement niya ay 0, 1, 0, 0. And then 0, 0, 1. So that's the one's complement. And then kapag nag-add nung MSB, ano kapag post complement, di ba LSB? For example, ay plus 1. So 1 plus 1 ay 2. Ano po? So dito po, sa padala. Then 1, 0, 0, 0, 1, 0. So this is complement. So ganyan lang po. Naunawaan dito. So yung one's complement, yung onset or tanang ang onset. And then yung offset or tanang onset. And then kapag two's complement at 1, ano, or LSB. So depende po kung ano pong given ang mapapabigay sa inyo. So, so may example naman po doon sa PowerPoint. Kapag ay sa addition and subtraction ay one's complement and then addition and subtraction to two's complement. So, next po is the binary coded decimal. So, same lang din po siya yung ating pong pinag-aralan. So, parang recall lang din yung pieces. Ayan. So, binary coded decimal. So, same lang. Binary coded decimal basically is another process for converting decimal numbers into their binary equivalent. So, it is a form of binary encoding where each digit in a decimal number is represented in the form of bits. This encoding can be done in either 4-bit or 8-bit. Usually, 4-bit is preferred. Ano po? It is a fast and efficient system that converts the decimal numbers into binary numbers as compared to the existing binary system. These are generally used in digital displays, whereas the manipulation of data is quite a task. But PCB plays an important role here because the manipulation is done treating each digit as a separate single circuit. So, mahalaga po na alam po natin kung paano yung decimal number to binary coded decimal. So, same lang po siya. Ano? So, tatandaan po yung PCB, binary coded decimal. So, 1, starting po lagi is right. Ano po? Right to left. So, yun lang. 1 is 0, 0, 2 is 0, 0, 1, 0, 3 is 0, 0, 4, 0, 1, 0, 0, and so on. And same lang po siya. Convert 1 to 3, 10 in BCD. Convert 3 to 4, base 10 in BCD. So, same lang po ito. Decimal. So, ang decimal nga natin ng number system ay base 10. to binary based. So dito sa PCT, hindi na po natin nilalagyan ng ah, conversion pa. So, matik na siya ay base. Hindi na natin nilalagyan ng base. Yung thus PCT becomes 001, 001, 0001. Diba dapat merong base 2 sa likod? So kapag PCT, binary coded decimal, hindi na po nilalagyan. Matik na po na siya po ay binary. Ano po? So it is noticeable that BCD is nothing more than a binary representation of each digit of a decimal number. So it cannot be ignored that the BCD representation of the given number uses extra bits which make it heavy weighted. So nagiging mahirap lang naman po siya kapag sobrang dami na. Kapag 16 bits na yung gamit. Pero usually po ang ginagamit po ay 4 bits and 8 bits. So, yun lang. So, si complements yung binary coded. Okay, in conclusion, kapag once complement, if merong negative, add D and SP. And then kapag two's complement naman, kapag may negative, add LSP. Ano po? And then binary coded decimal. So, decimal, number system binary. So, yun lang po. And then, ngayon po, tayo po ay mag-groupings. So, magkakaroon tayo na three members per group. 3 members per group for our laboratory. Excuse me. Na 51 nga pala. Wait lang. Check ko lang kung yung groupings.
Ma'am,
Yes po.
may groupings na po tayo.
May groupings na.
Meron na po, nagbigay po kayo ng last meeting.
Pwedeng mag-send sa akin. Wait. Maka-internet po. Wait ako ulit. Check ko lang. Yun lang po. Sobrang dami niya kasi. Kaya, nagugulat.
Ayun na po yung group chat. Ma'am, nandun po yung list.
Ayun. Hindi ko pala siya na. Sorry. Ayan, nakaka-upload. Pasensya na po, masyado makakalimutin ako. Thank you po sa nagpaalala. So, pinost ko na yung things and then add ko na din yung PowerPoint. Ayan, so pinost ko lang po yung atin yung instructional materials for complements and PCT numbers. Ano po? And then yung groupings. Thank you sa paalala. So, bali, next meeting ko po ibibigay kung ano po yung instruction. Rubrics para dun sa ating laboratory. So, standby mo. So, as of now, ituloy na lang natin yung ating discussion. And so, we're done with chapter 1, so number system, complements, and recipe numbers. So, tapos na tayo sa introduction to digital system. So, sana po, ma-recall po natin siya. So, kapag po kayo may time, balik-balik kayo ng mga instructional materials natin. Ano po? Okay, so, dito po tayo sa ating next topic, which is the Boolean algebra and logic gates. So, we will tackle about the basic actions and theorems, Boolean and functions, basic theorems, digital logic gates, canonical and standard forms of Boolean functions, algebraic simplification of Boolean functions, implementation of Boolean function in logic gates, none and more implementation of Boolean functions. Ano, so, yun po yung next topic natin. Ano, so, ang gagawin po natin, hihimay-himayin po natin sa Boolean algebra and logic gates. So, siya po ay medyo mahaba-habang process. Ano po?
Mapis kayo. Nung pasok ko yung Webes.
Ayan. So, Boolean algebra and logic gates. So, tumula tayo. Ano ba yung si Boolean? Ano yung mga logic gates? And symbols. Okay, so what is a Boolean algebra? So, Boolean algebra is a type of algebra that is created by operating a binary system. So, in the year 1854, George Boole an English mathematician proposed this algebra. This is a variant of Aristotle's propositional logic that uses the symbol 0 and 1. So, or true and false. So, Boolean algebra is concerned with binary variables and logic operations. So, meron po tayong mapapagdaanan na true, false is equals to false. Meron naman na true, false. The answer is true. Ano? So, ganun po. So, Boolean algebra is a fundamental in the development of digital electronic systems as they all use the concept of Boolean algebra to execute commands apart from digital electronics. So, this algebra also finds its application in set theory, statistics, and other branches of mathematics. And so, feeling ko, ito ay napagdaanan niya na senior high or first year. Napagdaanan niyo na po ba si Boolean algebra? Or si algebra lang? Anyone? Napagdaanan niyo na po ba si Boolean algebra? Akyawan na po ba sa inyo? Or ngayon pa? Or si algebra? Diba sa senior high, pinaka-basic ay yung algebra. Even sa first year. Sino yung mga ano dito? Yung mga math-unit. Meron ba mga sumali sa mga M? Meron ba? O wala?
Nagdaanan na po yan.
Napagdaanan na. Okay. So, ibig sabihin, mas maunawaan niyo na po siya. Ano? So, mas madali na sa inyo i-absorb. Ano po? Okay. So, Boolean algebra is a branch of algebra that deals with Boolean values to true and false. Ano, kahit sa kompuro, pinagdaanan ng si Boolean. Ano, kahit sa global, yes or no, true and false. It is a fundamental to digital logic design in computer science, providing a mathematical framework for describing logical operations and expressions. Okay. So, Boolean algebra, also known as binary algebra or logical algebra. So, binary number is base of 2. So, si 0 is off and 0 is false. So, 0 is low. And then, kapag naman 1 is on, 1 is true, 1 is high. Ano? So, on and off, siya po ay meaning in circuits. On and off, ginagamit with circuits. And then, true or false, dealing with true or false statement. Ano pa? So, yeah. So, complement variable with a bar over it. Then, literal variable or its complement. So, kapag complement variable with a bar over it, yung A, tapos may line sa taas. Ano? So, complement literal implicant meter tapos term. Ano po? So, kapag complement, lahat po sila may bar. And then, kapag literal, yung pangalawa. Ano po? And then, kapag implicant, it's either A, B, or C. Kapag midterm, ganun din. Ano, it's either ABC, 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 kung alin doon. Ano. And then max term sum that includes all input variables. So, ito naman ay may A plus and plus. Kung alin sa kanila. So, Boolean algebra operations. So, various operations are used in Boolean algebra, but the basic operations that form the base of Boolean algebra are negation, or not operation, conjunction or and operation, disjunction or operation, not and or. So, yun yung three basic operations. a Boolean algebra, not in or. Okay, so basic of Boolean algebra in digital electronics. So these operations have their own symbols and precedents, and the table added below shows the symbol and the precedents of these operations. These operators. So the operator is not. So ang symbol niya ay one quotation or ganun. Ano po? And then ang precedent niya ay first. Then in, dot, or quotation din siya, pero pabaliktad. And then second. And then or plus addition or then V. So kapag not first, precedent, kapag and, second precedence, and or is third precedence. Ano po? So kanina nakita niyo yung this. So kita niyo kung ano yung may bar. Ano, si first, and then and dot, second lang yung meron. And then kapag or yung third. Balikan natin. Ayan. Ay, ito po. Simula yung may bar. So negation or not operation using the not operation refers the value of the Boolean variable from 0 to 1 or vice versa. 0 to 1 or 1 to 0. This can be understood as if A is equals to 1, then using that operation we have A bar equals 0. So kapag lang po ni 1 to 0 and then 0 to 1. We also represent the negation operation as A. For example, is A is equals to 1 and then dash A is equals to 0. So yun po si that operation. 0 to 1, 1 to 0. So kapag na-convert mo siya to 1 or 0, dapat meron na siya bar or representation na dash. Next is conjunction or AND operation. So using the AND operation, satisfy the condition if both the value of the individual variables are true and if any of the value is false. And this operation gives the negative result. So this can be understood as if A is true, B is equal to true, then A dot B is true. So yung ginagawa natin nag-exam. So, A, B, C is true, and C is false. Nare-recall pa. So, yeah. So, if A is true, then B false. Or, A is equals to false, B is equals to true, and A dot B is false. Ayan. So, kapag end operation naman, kapag true, false, siya po ay false. And then kapag false, false. So, A and B is false. Ano, kapag N, siya po ay false. Ano, then kapag true, yun lang yun. Ano, kapag naman false, A is false, B is true, and then A dot is equals to false. Ano, so, si not operation, siya po ay 0 to 1. Kapag not operation, siya po ay 1 to 0 or 0 to 1. So, dito naman po sa end, operation true equals true. Ano pa? Pag true false equals false. Ano? Kapag false true is equals to false. And then false equals false. Ano? So, si true yun lang po yung true sa end operation. Ano ba? And then disjunction or operation. Or operation. Use or operation satisfy the condition if any value of the individual variables. It only gives a negative result if both the values are false. Ayan. So, again, si on end operation, kapag true false, siya po ay false. Sabi dito, kapag false, true, siya ay false. So, dito naman po, sa or operation, kapag true po, so A plus A is equals to B. So, true. And then, kapag A is equals to 2 and B is false, siya po ay true. And then, kapag false, A is equals to false and B is equals to 2, then A plus B is true. And then, kapag false, A plus B is equals to false. Ano po?
So, dagdag ko lang po dito sa maging kasaysayan. So, yung mga nagsipuntahan sa
So, kapag end operation, isa lang po yung true
bansa,
na answer.
sila po
Ano, kapag true. And then, kapag or operation naman, isa lang yung false. Ano, si false equals false plus false.
maikalat niyo
Or
lang.
A plus
Christianism
is equals to false.
diba?
Ano ba? Makita po ba yung differences? Ulitin ko po ha. The not operation, so 1 to 0 or 0 to 1. And operation naman, kapag true, siya po ay true. Kapag true, false, siya po ay false. Kapag false, true, siya po ay false. Ano? And then kapag false, siya po ay false. Ano? And then kapag all operation naman, kapag true, equals true. And then kapag true, false is equals to true. False, true equals true. And then false, equals ano, vice versa po si end operation or operation. Ano po? Nagets po ba? Okay na po. Nagets na po ba? Yung basic operation in Boolean algebra.
Yes.
Okay po. Thank you. Yeah. So, Boolean algebra po. So, operation. So, si end operation or operation, not operation. So, that is the three basic operation na ginagamit natin. Ano po? And then, we also have XOR operation, NAND operation, NOR operation, and XNOR operation. Ano? So, yung apat po yung mga additional operation na ginagamit natin for circuits. Ano po? So, yung symbol, the end, operation dot, or the na kabalik na. Ano? So, returns to only if four inputs are true. And then, for operation returns true if at least one inputs is true.
Binigyan daw po sila, binigyan daw po ng
Ano? And then, not operation reverses to input.
lang natin na
Ano? So, hindi lang po siya for 1 to 0, 0 to 1. Pwede din po siya maging A to B, B to A. Ano? So, ganun din. Pwede din po siya sa charge about sa character. And then kapag export operation naman returns true if exactly one input is true. So, parang siyang or operation. So, teka. So, kapag non-operational returns false only if both inputs are true. So, kapag siya ay same with and naman. Teka. So, non-operation returns false if at least one input is true. And then X more returns true if both inputs are equal. So, dala niyo po ng symbols. Maging familiar po tayo sa symbols. Sorry. Excuse me. Yeah. So, maging familiarize tayo sa mga symbols para kapag makita natin kapag more on symbol na so ma-identify and to or to not to X nor non-X nor so di na po kayo malilito so take time to review the symbol operation of this definition isasend ko naman po ng PowerPoint after our discussion since kayo po ay inahati-hati natin yung topic sa chapter 2 so tandaan po wait inuna po Okay, sorry. Natagalan na sa pag-inom. Dumating kasi yung isang prof for the logic circuits. So yung laboratory is about the multimeter. So, pag-uusapan pa namin ano yung atin laboratory 1. Kasi yung multimeter na yun is gagamitin niya pa sa susunod. Kasi gagamit talaga tayo Arduino. Breadboard. Ano po? Okay. So, going back to the slide. So, be familiarized with the symbol and the definition of the operations na ginagamit natin. Lalo-lalo na yung basic operation, the AND or NOT. Ano po? So, Boolean expression and variables. Boolean expression is an expression that produces a Boolean value when evaluated. It produces either a true value or a false value. Whereas Boolean variables are variables that store Boolean numbers. Okay, so P plus Q R is a Boolean phrase in which P, Q, and R are Boolean variables that can only store two values, 0 and 1. The 0 and 1 are the synonyms for false and true and are used in Boolean algebra. Sometimes you also use yes in place of true and no in place of false. So thus we can say that statements in Boolean variables operating on Boolean operations are Boolean expressions. So some examples of the Boolean expressions are so A plus B equals to A is equal to true. A or equals false. Okay. So, alam na natin kung anong operation siya. Ano? Okay, so Boolean algebra terminologies. So, palagi ito papanag lagi kayo magtatagpo nito. So, there are various terminologies related to Boolean algebra which are used to explain various parameters of Boolean algebra. So, that includes Boolean variables, Boolean function, literal, complement, truth table. So, Boolean variables. So, yun lang kanina sinasabi natin. Ulit na tayo nagsasalita ng 0 and 1, true and false. So, what is Boolean variables? So, Boolean variables are fundamental in representing logical states or proposition in Boolean expression and functions. So, Boolean functions are functions of the Boolean algebra that is formed by the use of Boolean variables and Boolean operators. It's called the Boolean function. So, kapag nagsawa daw pala po si Boolean variables and operators, ang tawag po sa kanya ay Boolean function. It is formed by combining Boolean variables and logical expressions such as AND, OR, and NOT. So, atin po tatlong basic operations. So, it is used to model logical relationship, conditions, and operations. Yes, that is Next, a literal, a variable or the complement of the variable in Boolean algebra is called the literal. Literals are the basic building blocks of the Boolean expression in functions. They represent the operands in logical operations. So, diba, the arithmetic operations, addition, subtraction, multiplication, division, modulus. And then we have the logical operations. So the logical operations, so that is the AND or NOT. It's all non.
So, meron pa yun, kung merong existing
And then complement. So the inverse of the Boolean variable is called the complement of the variable. So the complement of 0 is 1 and the complement of 1 is 0. So saan po ginagamit si complement? kay not operation. Ano? So 1 is 0, 0 is 1. So that is complement. So it is represented by bar. Ano? So bar or gano'n. Hindi ko alam kung ano tawag sa operation. Basta ang nakalagay lang kasi sa kanya is bar. So yung symbol na yan, parehas ay, ang tawag ay bar. Ano? So over the variable. So complements are used to represent logical negations in Boolean expressions and functions. So the 1 to 0, 0 to 1, ang tawag pala sa kanya is complement. Ano po? So kanina, the 1's complement, 2's complement. So, next, ayan. So, truth table. So, kung malilito dito, ay, medyo nakakalito ka sa una. Ano? So, table containing all the possible values of the logical variables and the combination of the variable along with the given operation. Okay, so the table contains all the possible values of the logical variables, and the combination of the variable along with the given operation is called truth table. So the numbers of rows in the truth table depends on the total Boolean variables used in that function. So it is given by using the formula. So this is the formula. Number of rows in truth table is equals to n. So where n is the number of Boolean variables. So para po siyang yung ating pagkakalo sa weight 0 to weight 1 or 2 exponent of 1 exponent of 2 exponent of 3. So that is the formula for the truth table. Ayan. So, example, draw the table of the condition A plus B and A dot B, where A and B are Boolean variables. So, solution, the required table is. So, yeah. Ito po ay kay N at saka I or. Diba? So, kapag N operates, kapag true to, siya po ay true. Ano? So, lahat to lang. True to, true. And then, kapag false, lahat or and is false. So, dito lang po siya nagkakaroon ng difference kay true, false, at kay false, true. So, kapag kay or and so true, false, true, and then false. Kapag naman false, true, then true, then false. Ano po? So, kapag po tayo ay nagagawa ng kunyari, compute. So, parang mas maganda or I prefer na magawa mo na kayo ng truth table para hindi kayo malilito. So, yeah. So, ganyan po yung nagagawa ng and then, yeah, Boolean algebra rules.
Pero nandito ko lang kasi sa una.
Okay. So, in Boolean algebra, there are different fundamental ways for logical expressions. So, binary representation, in Boolean algebra, that variables can have only two values, either 0 and 1, where 0 represent low and 1 represent high. So, these variables represent logical state of that system. Okay. And then complement representation naman, the complement of the variable is represented by bar. So, yung dalawang symbol na yun ay bar over the variable. So, this indicates logical negation or inversion of the variable's value. So, complement of variable A can be represented by A bar So if the value of A is equals to 0, then its complement is 1. So the answer is A bar equals 1. Ano? So kapag hindi pa siya nako-complement, wala pa siyang mark. Ano pa? So kapag binary representation, 0, low, 1, high. Kapag complement, kapag the given is A equals 0, then the answer is A bar 1. Ano pa? So or operation is represented by plus sign. Ano pa? Tandaan, or operation represented by plus add sign. So between the variables, our operation returns true if at least one of the operands is true. So for example, let us take three variables A, B, C, and the OR operation can be represented as A plus B plus C. Diba? So kapag OR, siya po ay plus plus. Ano? So kunyari binigyan tayo ng given turn to OR operation. So ang gagawin lang po natin ay A plus B plus C. Paano naman kapag BCT? So B plus C plus D. Ano? So ganun lang po. And then end operation. So is denoted by point. Ano? So and then po end operation denoted by point. Between the variables and operation returns true value if the operands are true. So for example, let us take three variables, the ABC, and end operation can be represented A.B.C or ABC. So yeah. Conclusion. Pinaikling version. So kapag binary 1 sorry, and then every component variable is represented by over bar. So variable or ay plus sign, then kapag logical is ay dot A, B, C. Ano? So nagets po ba ang ating po three basic operations na ginagamit? Sinat operation, end operation, or operation. And then yung rules niya, ano po, truth table, naunawaan po ba? Heart react po kapag po naunawaan. Ayan, isa na. Ayan, nakadalawa. Tatlo. Apat. 5, 6, 7. Ayan. So at least, na-recall po. So, next po. At least, sorry. Wala na pala. Okay, so basically, hanggang dun muna po tayo. And so, do you have any questions about Boolean algebra? Meron po kayong questions? Naintindihan naman po. Madali lang po. Madali lang po. Yes or no? So kung wala na po kayong question, please open up your cameras. Kung wala na kayong questions, pa-open po ng cam. Pa-open po ng cam. Maltese, Pangaliban, Uli. Yan pala nakita ko, si Plenofred, Daniel, ang Shoko, Daniel.
Hindi ko po kasi yung gusto tumasampung. Doon na taga ng utakampung on the spot.
Okay, so, yung una ko pang sinasabi sa inyo, una ko pang sinasabi sa inyo na kayo po ay mag-ipon. Ano po, dahil tayo po dyan ay gagastos po for ating logic. Logic circuits. Pero magagamit nyo naman yan sa lahat ng ating pong activity na gagawin. Ano po. So, pinag-uusapan na po namin kung ano pa po yung first activity. Since halo-halo po kasi siya. So, gusto namin step by step, basic to basic. Ano po. So, pa-open na po ng camera natin.
Hindi, mali.
Wala na, ito lang. Okay ng cam.
CPE, ganun naman. Basta tumawala na.
Wala na.
Hindi, bukas mo. Hindi.
Nag-screenshot na po ako. 1, 2, 3. Smile. Smile po. Okay. Isa pa. Natawa si Mendoza. Christy. Tinatawanan ako ni Christy. Isa pa. Okay, 1, 2, 3. Smile. Ayan. Thank you so much, guys. Thank you so much, guys. God bless. Sana po may natutunan.
Thank you po.
Thank you po. Ma'am.
Thank you po, ma'am.
Welcome. Sana po may natutunan. Kahit pa paano.
Gagawin dapat mag-format eh.
Magpapasa po nung last PPT na lang po sa Dilas. Thank you.
Yes po. Thank you sa pagpapaalala, Miss Rosales.
Wala akong laptop. Hindi, dali na. Dasal pa mo lang. Tapos pag nabuhay mo, pwede
Pwede na po tayo mag-leave. If you have questions, pwede naman.
Tapos, ito ang ito. Sasalat mo.
May questions pa po. Leave ko na po yung call. May questions pa po. May questions pa po kayo. Or nakatulog na po.
Tama din naman, delete. Hindi.
May questions pa po. Pwede na po mag-leave. May questions pa po ba? Hello. Hi. Annyeonghaseyo. Sawadika. Hoy. Tinulagan niya ako. Landicho.
Anong year? Anong course yun? PE? PE?
Hello. Hi. Hello, welcome to Jollibee. See you next meeting, guys. Bye. Okay.